All right, guys, today's going to be a little bit different. I'm going to show you the finished parts of an assembly that I only had a few days to make. Material came in a little late. It was kind of a last minute thing. We wanted to measure the piece of glass that goes in here before we actually made the parts. So crank this out in 2 days. Okay, so the reason that I'm wearing gloves and handling this is it's coated with a very, very black paint, actually. This paint's pretty commonly available. It's just Rust-Oleum. It's camo paint, camo flat black. It is absolutely the blackest paint that you can buy commonly without spending crazy amounts of money on Vanta Black or something like that. So it's a little bit delicate. We don't want to scratch it up. There are two parts here. There's the main ring has these ears on it, and then the bolts hold in a little flange. You can see it right there. A little flange that locks the optic, the lens, basically. Well, it's a filter. Locks a piece of glass in. There's two O-rings that kind of tighten it up against the frame and prevent metal-on-metal contact. So that's what's going on. Now I'm going to show you the process. Well, first I'll show you what it's going in and a little bit of the history of that. And then we'll go through the CAD and the CAM, and there's the finished part. All right, so we'll go over the CAD right now, and what you can see on the screen right here is SITELLE. Now, SITELLE is a Fourier transform imager. That means it's got two cameras. You can see them in the orange or in the gold here. They're about 45 degrees apart on angle from the incoming light, and each one of these cameras has a CCD, a charge coupled device inside, and basically this is an integral field unit. It gives a spectra of all pixels in the field of view, and I believe these are both 4K CCDs. So this is a fairly large amount of data each one of these pictures has, and I'll provide a link to the SITELLE webpage. I've got it up on the screen right here. I'll provide a link to that in the description below, so everybody can go out and read about this thing. Anyways, you can see in the CAD here where this filter wheel is located is right up here. So if I zoom in right here and go ahead and maybe take this and hide it, there we go. There's where our 6 filter wheels are, behind these carbon fiber tubes. So basically what I had was this as CAD data. Now if I take this piece and I open this part up, you'll see over here that this is nothing more. I was provided nothing more than a step file. The entire instrument, all we were given was a step file. So I reverse engineered the entire thing and rebuilt both parts and imported them into Mastercam. All right, guys, so this is the process I use to rebuild these things, basically. So when I open up this part right here, it says it's an older file version. That's fine. Okay, so what we've got is, you can see right over here, it's a step file. It's just a bunch of dumb geometry. So the cool product is in data migration, recognize features, and we'll just run through this. I just select it as is, and it's going to go ahead and rebuild this thing for us, recognize most all of the features, and do it pretty well. This is SolidWorks just going. Boom, there it is. So what I see right off the bat is it did not capture this radius out here on these two, so I had to go in and fix that. And also, if I look at the holes, you've got a 5mm diameter hole here, and you've got 2.5 there. Those are 3mm tapped holes, and these are 6mm tapped holes. Again, that's where you'd need the part or a drawing to figure out what these holes are. And of course, I don't have any tolerancing data on this, which is the big problem. But I know what it goes in, and we were able to derive the correct numbers for this inner bore, which is really, and the depth of the step, which is really the only crucial thing in this design. Depth of that step and the diameter of that bore. Anyway, that's how I do it with data migration and recognized features. You end up with a full tree that you can then modify and modify to suit your needs, I guess. Okay, so one of the interesting things about SITELLE is that this is not the first part I've made for it. In fact, I've made many parts. And you can see right here on screen, if I zoom in, this green part right here, if I go ahead and open that guy up, now you can see that this is very unlike the others. This is not originating from a step file. So this was created by me, and then this was the piece that was machined in the SolidWorks video that kind of we were featured in. So I'll go ahead and put a link to that video. I think it goes right up there. So you can check that out as well and see what we do more. Anyways, not our first go around with this instrument, and dealing with these interesting, like all we're provided is barely enough data to keep it going. Now, we don't own this instrument, but we are charged with maintaining it. It's kind of difficult when they don't give you enough information, like you know, yeah, we're given a step file of the instrument, but that doesn't really help with like fit tolerances for holes and whatnot, so it can be difficult. Okay, so we're out in the shop. I'll go ahead and show you a little of the cam. Some of it I'm going to hold a little close because there's some fixturing involved that that allows this to happen. These wall thicknesses are extremely thin, and to get this thing to cut and provide a great surface finish is a little difficult. And still, even with this fixture that I've figured out, I still have to, and check out right here, I still have to go ahead and cut this pretty slow. You can see here's the part. I'll zoom in a little bit. Interesting thing is that these bosses that stick up to locate this thing, they're not all the same size, and they are very close to this wall right here. So you can only get in here and cut this with so big a tool. So let's see, to rough this guy out, I think maybe, no, this is the finished pass. I've already roughed it out, and I'm taking just maybe, I think it's 10 thou. I'm taking the remaining 10 thou off, and right here, let's see if there we go. So we're doing 15 thou step downs, taking 10 thou. Now again, you got to understand where I work. Where I work, we're not making 100,000 of these parts. We're not making 100 of these parts. We're not making 10 of these parts. I made 2. And what's crucial being in Hawaii here is that I not break a tool, because that'll take another week to get one, and I not destroy the material, because that will take another week to get more material. The material that this was cut with is Mike 6, so it's cast aluminum. But that just kind of shows you the level that I go to here sometimes to ensure the success of what we're doing. So there's the remaining passes, cleaning up the rest of this guy. But yeah, it's got little chamfers on the top and bottom. It's got chamfers on the bosses. These are threaded. This is 6mm. This is 3mm. On the back side that we did first. First we did the back side out of a piece of raw stock. This little arrow was cut with a 1/32 end mill. Kind of a cool tool path. I believe we used Opti-Rough and had it doing just tiny step overs, 10 thou, 15 thou. But basically it plunged in this in the hole, the threaded hole, and just came in and knocked this out really quick. And I had it doing short it cut this in 3 passes. So just like I think this is 33 thou deep, you know, millimeter, something like that. And so I did it in 3 goes, and it still only took 5 minutes or something. So again, it's not production. Nothing I do is for production ever. I just have to make the part, make it successfully, and make it on time. That's the crucial part. So you can see I did a whole bunch of projecting lines and surfaces that I could use for whether it be pockets. You can see over here we did a pocket right there. That whole top surface was done as a pocket with varying layers of depth cutting. I think I used a 1/8 end mill just so I could get around the back side of this between these 2 areas. Yeah, so there you go. Okay, so this part right here is the ring that bolts into the to the actual holder itself, and it's symmetric, 120 degrees apart on these little flanges right here. And I did not cut this surface right here. I did not cut that. A countersink, it's just not that important for this application. I did that secondary operation on the Bridgeport, and I'll show you that setup. Pretty easy. Let's see. Let's view isometric. So that's how it's positioned in the machine, with Y being out front here, X running across, and of course Z up and down. The first thing I did was I made a fixture. This is just a flat plate, not a big deal. I peck drilled and tapped a hole for each one of these to be bolted to, and then came in, contoured out the inside. Of course, that leaves this big puck in here to float around, so you got to stop the machine, pull the puck out, restart everything, and do the finish cut, so you don't break an end mill or worse. Once that's done, the next thing was a contour. I finished the top surface, brought it down to height, which was very critical because this piece of glass has a certain height. We don't want to crush the O-rings too far. We want to hold that piece of glass so it's not moving around at all, but not over constrain it. And then the next operation I did was on the outside, down to those little flanges. And then what we did was, oh yeah, that's taking care of this little chamfer. You can see a 2D chamfer right there. And then the next operation, I believe, was drilling. So we came in with an end mill, the 1/8 end mill that I cut all this with, because that's a good size clearance hole for 3mm. So we punched those holes, bolted it down, and then finished up with the contour around the perimeter of the part. Okay, we're out on the Bridgeport, and you can see right here, this is my setup. It's just the right angle, of course, metric stuff, so it's not 90. It's got the right angle, and all I did was I used this to hold the edge of the ear, and then supported that ring out here on the top of the vise, and just put this guy in until I hit, I believe up here, until I ran this guy down to 0, basically. So once I hit 0, I knew I was there. And when this is cutting 7 series, and that's what those retaining rings are made out of, 7075, this thing don't move so easy, so it's easy to creep up on 0. It takes a minute to cut that stuff. So yeah, that's that setup. All right, so here's the material that we cut the main body out of. Again, it's Mike 6. So that's cast aluminum plate. I believe this is 1 inch by 12 inch square. And then this guy. This is the little retaining ring, 3/8 thick, 70-75, 8 inches square. And a good bit of material was left over from both operations. These were just commonly available and quick to get here, and I bought them on McMaster-Carr. As far as paint goes, this is what we used. Self-etching primer, really super light coat of this. And believe it or not, this Rust-Oleum Camouflage Black is incredibly black. And we test this. And this guy wins hands down over everything we were able to test. So this is our go-to right here. If you need something black, that's black. Okay, so there's the rundown of what we did here in the shop for the past few days. Couldn't take you along for the ride because I had to move fast and setting up a shot and all that. It's just it wasn't time for that. So there's the finished part. And again, this goes in the instrument SITELLE, which is a Fourier transform spectroscopy machine. If you want to know what that does, again, I've put the link down in the description, and you can read all about it and become an astronomy nerd. This holds a $13,000 piece of glass with a very specific coating to only allow or block certain light from going through. And that's what we do. So anyways, like, subscribe, share, and provide in the comments anything you'd like to see, specific information or skills or cutting paths, or I mean, just let me know what you want to see, and I can tailor my content to exactly that. So anyways, like I said, stay tuned, more good stuff coming.